Example number 65, solve the following logarithmic equation. Log x to base 4 plus log 16 to base x is equals to 3. Remember, this is log x to base 4. 16 can be written in terms of 4, isn't it? So that here we have log x to base 4 plus log 16 is the same as 4. 4 squared to base x is equals to 3. So here we have what? We have log x to base 4 plus this 2 is the coefficient, isn't it? Plus 2 log 4 to base x is equals to 3. So look at this and this. Remember, if we have log b to base a, this is the same as 1 over log a to base b, meaning one is reciprocal of the other, isn't it? So it means when you have log x to base 4 and here is log 4 to base x, one is reciprocal of the other, isn't it? So what do we have here? Here we have log x to base 4, then it is plus 2 into 2 over log x to base 4. Because it is the reciprocal, log 4 to base x, when you take the denominator, it now becomes log x to base 4. Are you seeing that? Then the reciprocal to be equals to 3. So you can see this is now the same as that. So you can now say let y to be log x to base 4, because we cannot use the laws of logarithm because of division, isn't it? Are we together? We cannot use laws of logarithm because of division. So we let log x to base 4 to be y, isn't it? If we let it to be y, we are now going to have this is y plus 2 over y to be equals to 3. So what do? You multiply both sides by y to get rid of the y in the denominator. So if you multiply both sides by y to get rid of y in the denominator, what do you get? Y times y. You have y squared plus y cancels with this y, isn't it? You get 2 to be equals to 3 times y, you get 3y. So can you now solve this? So you make it in form of a quadratic equation. Are we together? So you get y squared positive 3y coming this side, it becomes minus 3y plus 2 is equals to 0. So from there, can you use factorization? A product of 2 and a sum of negative 3. Yes, that is negative 2 and negative 1, isn't it? So this means you have y squared minus 2y minus y plus 2 if you use factorization, isn't it? So here y is a common factor. You remove y outside, you remain with y minus 2. Here negative 1, then you remain with y minus 2 to be equals to 0. Because negative 1 times negative 2, you get back to a positive 2. Are we together? So after that, what do we have? We have y minus 1 and y minus 2 is equals to 0. So it is either the first factor which is 0 or the second factor which is, so either y minus 1 is 0 or y minus 2 is 0. So what is the value of y? Y is equals to 1 or y is equals to 2. Is that okay? But what was y? See, you take back the value of y. Y was log x to base 4, isn't it? Y was log x to base, so where there is y, you put log x to base. Log x to base 4 is equals to 1, or log x to base 4 is equals to 2. Is that understood? Where there is y, you put the value of y was log x to base 4. You get that. Having found that, you now start by this. If you have log x to base 4 is equals to 1, see 4 is the base. 4 is the base, 1 is the index, then log of corresponding number. X is the corresponding number. So you get x is equals to 4 raised to power 1, meaning x is equals to 4, isn't it? See, that's the first method. Another way to get it, if this is base 4, meaning you introduce log 4 to base 4. A log of a number to the same base is 1, so that this coefficient 1 becomes the power. So you see, you have a single term on both sides, meaning you can now ignore log to base 4 on the other side of the equation, isn't it? Then you remain with x is equals to 4 raised to power 1, which is just 4. You see, you can use the definition or laws, isn't it? Then the second one, you have log log x to base 4 is equals to, so if you use definition, the base is 2, the base is 4, the index is 2 is equals to x. Meaning from here, by definition of logarithm, you get 4 squared is equals to x. Meaning x is 16, isn't it? That one if you use definition, okay? But now if you use the laws of logarithm, if this is to base 4, meaning the other side, you introduce log 4 to base 4. Log of a number to the same base is what? Is 1. Then this coefficient becomes the power, like that. Are we together? So you can see we have a single term on either side of the equation. Log to base 4, log to base 2. A single term on either side of the equation is when you are able to ignore the log. If it is only a single term, you see? So that you remain with x is equals to 4 squared, which is 16. So we found the solution of x is either 4 or x is 16. Is that understood? Are we together? Good.